Hello students, the question says express this quadratic in a complete square form. So to answer this part, we'll first write down the quadratic equation, which is x squared plus 6x minus 5. So, and then we'll compare it with the standard quadratic equation of x squared plus bx plus c. So the value of a that we get is 1, the value of b that we got is 6, and the value of c that we got is minus 5. So the completed square form has the formula y is equal to a into x minus h whole square plus k. So to calculate the value of h, the formula is minus b by 2a. And to get the value of y, so we have f of h, which gives you the value of k. So now we'll first calculate the value of h. So h equals to minus b, that means minus 6 by 2, which is equals to minus 3. So that's the value of h. So if I'm calculating the value of f of minus 3, so that means I'll put minus 3 into the original equation. So that is minus 3 whole square plus 6 into minus 3 and minus 5. So that is equals to 9 minus 18 minus 5. So that is equals to 9 minus 23, which is equals to minus 14. So that means if I put now the values into this formula, so the square form will be completed. So that means y is equal to, so the value of a is 1 and is x minus h. So that becomes x plus 3 whole square and it's plus k. So that becomes minus 14. So that's the final answer for part A of the question. Similarly, moving on to the part B of the question, it again says complete the square in this. So we'll again compare and make the same initial steps. So in this case, the value of A that we got is 2. The value of B is 12 and C is equals to minus 5. So again, I'll calculate the value of H, which is minus B by 2A. So that's minus 12 by 2A, which is 4. So that is equals to minus 3 again. So if I put the value of f of minus 3 into the original equation over here, so I get 2 into minus 3 whole square plus 12 into minus 3 minus 5. So that becomes 18, and this is minus of 36 and minus of 5. So that is equals to 18 minus 41, and that is equals to minus of 23. So that's the value of k. So to answer the B part, so again the equation becomes y is equal to a into x plus 3 whole square, and plus k means again minus of 23. So that will be the final answer for part B of the question. Now moving on to the part C of the question, it clearly says express this into this particular form. So to answer for the part C, we'll write down the quadratic equation, and we'll also write down the form which they have asked us to express it. So that's this. So we'll expand this, so that becomes minus q. If I expand the brackets, so I get x squared plus 2xr plus r squared. So if I open up, so that becomes p minus qx squared plus 2rqx, where that should be minus, and minus qr squared. So I'll compare it with the quadratic equation given here. So the coefficient of x squared is minus q and the coefficient of x squared is here is minus 2. So I can say that minus q equals to minus 2. So that literally means the value of q that I got is equals to 2. Now I'll compare the coefficient of x on both the sides. So that is minus 2rq equals to minus 4. So minus 2rq equals to minus 4. So if I cancel out the minus sign, the value of q we know is 2. So that becomes 4r equals to 4. So the value of r that we got is 1. Now if I compare the constant part, which is p minus qr squared, and that should be equal to plus 1. So we don't know the value of p, but the value of q is known to us, which is 2, and the value of r squared is 1. So that is equals to 1. So the value of p that we got is 3. So once we got the value of p, q, and r, so we can place it over here. So that becomes 3 minus the value of q is 2 into x plus 1 whole square. And that will be the final answer for part C of the question. Now moving on to the part B of the question. It says that express this quadratic into this form. So D part 1, I'll write down the quadratic equation once again, and I'll compare it with the form which they have given us to express it as. So again, I'll expand here. So I can write it as x squared minus 2ax plus a squared plus b. And if I compare the coefficients of both the sides, if I compare the coefficient of x squared, that's 1. If I compare the coefficient of x, which is minus 2a, and that should be equal to minus 7. So that means the value of a that I got is 7 by 2. Again, I'll be comparing the constant part, which is a squared plus b equals to 15. So that literally means a squared plus b equals to 15. And the value of a squared we know is 49 by 4 plus b equals to 15. So the value of b that we got is 15 minus 49 by 4. So if I take up an LCM, so that's 4. So this becomes 60 minus 49. So that is 11 by 4. So that's the value of b that we got from here. So that means the equation can be expressed as x minus a whole square. That means x minus 7 by 2 whole square and plus b, so which is plus 11 by 4. If I'm answering for the second part of the question, so that means the equation can be written as 1 by x minus 7 by 2 whole square plus 11 by 4. So they have asked us to find the maximum value of the function. So a function can be, or a fraction can be maximum if the denominator is minimum. And since this is a square, so we know its minimum value is 0 because a square cannot be negative. So if I put its minimum value as 0, which is the minimum value for the denominator, so that becomes 0 plus 11 by 4, and that becomes 4 by 11. So this becomes the maximum value of the function. Since denominator is minimized, so the fraction is maximized over here, and that will be the final answer for this question. Thank you, students.